In this video, we are going to learn about the state transition diagram and we're going to learn some important terminologies and concepts which are useful to understand about the CPU scheduling algorithms. In the last OS class, we have discussed about the states of a process. We have discussed that a process is newly created is said to be in new state, and the process which is ready to be executed by the CPU is said to be in the ready state, and the process which is currently being executed by the CPU is known as in running state, and the process which completes its execution is known as terminated. Now, we have included another state that is called suspended. First of all, let me explain about the degree of multiprogramming. Degree of multiprogramming is defined as the maximum number of processes that can be stored in a main memory at a time. For example, if we have a main memory with capacity of 100 programs, then its degree of multiprogramming is said to be 100. Let's take a scenario where the degree of multiprogramming of the main memory is 100, but the processes in the ready state are 120. Then the main memory will replace the 20 processes from main memory to the secondary memory. Then the processes which has been replaced from the main memory to the secondary memory are said to be in suspended state. And once the CPU executes the processes which are which are in the ready state, then an empty space will be created in the main memory. Then the processes which are in the suspended state will be transferred from the secondary memory to the main memory. Let's discuss about the schedule. Scheduling means deciding. It means we'll decide which process to be executed by the CPU first. And the scheduling can be based on the priority of the processes, or it can be based on the arrival time, or it can be based on the burst time of the processes. There are many scheduling algorithms, and each algorithm will have its own advantage and disadvantages. In the process of scheduling, there are mainly two components which plays an important role. First one is the schedulers, and the other one is dispatchers. As I told that these schedulers are responsible for deciding which process to enter into the running state, or if we take the state of new state to ready state, these schedulers are responsible for deciding which process to go into the ready state from the new state first. And this dispatcher is actually responsible for transferring the process. It also maintains the last state of the process and loads whenever it transfer the process to the CPU. And there are mainly three types of schedulers. First one is long-term scheduler. Long-term scheduler is responsible for deciding the processes which are in the new state and which has to be transferred to the ready state. Decides, it defines an order of schedule in which the process should be transferred from the new state to the ready state one by one. Responsible for for the transfer of programs from new state to ready state. Similarly, the next one is short-term scheduler. These are mainly responsible for scheduling the programs from ready state to the running state. It means these are responsible for transferring the programs from ready state to running state. And the last one is middle term scheduler. Middle term schedulers are responsible for making the schedule of processes from the ready state or the block state into the suspended state. It decides which process to be suspended from the ready queue or block or waiting queue. Now, let us discuss the important terminologies that we have to know to understand the scheduling algorithms properly. Here, we mainly focus on the scheduling algorithms of short-term scheduler, and the remaining is almost the same. The first one is the arrival time, and the next one is waiting time. We also have burst time, I/O burst time. The next one is turnaround time, and the next one is completion time. Along with these six, we also have some other terminologies like schedule length, and dispatch time, or this is also called as schedule overhead. And the last one is throughput. Let us see the definition of all these terms one by one. The arrival time. Arrival time is defined as the time at which the process enters into the ready queue first time. For example, if we have n processes and the process P3 enters in the ready queue at t is equal to 5, then these 5 seconds is said to be the arrival time of the process 3. Time of arrival. Waiting time is defined as the amount of time that has been spent by the process waiting in the ready queue. The next one is the burst time. Burst time is defined as the amount of time spent by the CPU in order to completely execute the program. Spent by the CPU to execute the program. I/O burst time, the time spent by the program in order to complete its input and output operation. I/O. Turnaround time. Turnaround time is defined as the total amount of time that has been spent by the program in the ready queue. Turnaround time can be calculated by the addition of burst time plus waiting time. Next is the completion time. Completion time is defined as the time period at which the program is completely executed by the CPU. And completion time can be calculated by the addition of arrival time plus turnaround time. Time at which program is completed. The next one is the schedule. Schedule is an order of processes in which they have to be executed by the CPU. It can be simply said as order of processes. Schedule length, the amount of time that has required by the CPU to execute all the end processes of the schedule. Total time taken to execute all processes. The next one is the dispatch time. As I told you that dispatcher is responsible for transferring of program from one state to the another state, and it also loads the last state of the program. So it will take in this process it requires some time. So the time required by the dispatcher to switch, it is also known context switching, to do the context switching is called as dispatch time. Time taken by the dispatcher for the context switching. And the last one is the throughput. Throughput is known as the efficiency of the CPU. It is defined as the number of processes executed by the CPU in unit time. This is all about the important terminologies which you should understand get a good idea on CPU scheduling. And in the next OS class, we're going to start the scheduling algorithms. Thank you for watching.